I'm now going to show you how you can use infinite procedural terrains and set up spherical scenes and planetary terrains. So I'm going to start by creating a new scene, going to my options, turning off the incorporation, and while we're in the options, we can set up the infinite procedural terrain geometry size. So how large the proxy object is going to appear within LIghtwave. So the default that is set is 150 kilometers. We can go ahead and modify this value, or we can just keep it at the default. I am going to reduce it to 75 kilometers. And go ahead and click OK. So now I go ahead and save out this separate view scene. And I'm just going to call this infinite terrain. Okay, so to load in an infinite terrain, or to create one, you can load from a preset, or you can create your own. We're going to start. I'm going to show you how you can load in the presets. Under the Create tab, you can go to the Procedural Terrain. So create procedural terrain from procedural terrain preset, where you have the option to load in just procedural terrains that can be saved out, or a selection of infinite terrains. So I'm going to load in the brown preset, and the brown terrain. And I'm going to go ahead and switch over to the perspective view. We can take a look at the scene. So as we can see, we have a very large object creating the terrain. In this case, if we wanted to be out this far, we would need to drastically change the grid size, which I'm doing with the right and left bracket keys. Now, also keep in mind that we do have a ground plane within the scene still. So if you don't feel you need the ground plane now that you have this massively large terrain, you can select the terrain and clear that out. But it does look like that when I loaded in the infinite terrain, it did automatically delete the ground plane and did replace it with the sea level object. That's because, more than likely because of the settings I have set up within the standalone version, where I've basically set the panels to no longer ask me if I wanted to keep it or delete it. So my default is typically to delete it. Either way, we don't really need it. So if we want to see a larger version of the C object, which is this plane, we need to increase the scale of the infinite plane geometry size. So let's go ahead and bring that up to 25 kilometers. And that's going to scale this low-res object that is representing the sea. And that way we can see if we want to have the water rendering where it's going to intersect with the terrain. Also, setting the sea level does change where the horizon is. And where that altitude will start. If we go to select the sea level object and edit the object, or actually we'll go ahead and go to the object properties. It is currently set to be hidden from the render by default. Once again, I think that's more than likely because of my settings that I chose to check the checkbox that said not to ask me again. Otherwise, you might get some pop-ups that will ask you if you want to add in the sea level object. And so in the properties, we can see that it's hidden from the render. If we go to edit the material, one of the reasons why the proxy object is white and not showing up blue, which would be the overall color of the water, is because of the foam layer. The foam layer overall color is white, and the top material of a material list or material layers is going to create that overall color. So you can edit the proxy material, although it probably revert back to the white color. If you're not going to be using the foam, you can remove it completely. Foam is generated by using the foam along coast option. There is a foam meta node where there are some different options to modify the foam. You can go in and edit the meta node and set up the typical depth. So the depth the objects need to be in order to create foam, and setting up the distance to the object below, which is the primary input to calculate the foam. It takes the distance from the objects below the water level, and any objects below that water level extending to the defined value will generate foam. By default, the water object is set to a distance unit of the internal view unit, which we currently have at 1 meter. So that way it's pretty easy to figure out the coast foam depth, which is set to 2, so 2 meters. So we should be able to see 2 meters from the coast foam being generated. So I'm going to turn on the render of the sea object. And for now, I'm going to go ahead and switch over. Well, can eventually need to switch to the camera view anyway. So go to the main camera, and we're going to just move it up a little higher. And the calculation to create all of the geometry out to the horizon can increase render times by quite a large amount. The geometry is calculated dynamically based on the height of the camera in relation to the object. So although this is not dynamically shown within LIGHTwave, if you were to go into the standalone version, we would see the geometry extending, and also the procedural terrain moving with the camera. So the higher we pick up the camera, the more of the terrain is created to fill to the horizon. If we limit the view, so going into the camera view and setting the rotation downward, what is being calculated for the render is really just what's directly in front of it and within the camera extent. So that does make it a little bit easier to limit the range just by pointing the camera down, especially for any sort of test renders, anything like that. I'm going to go ahead and set this up for a different resolution. I'm going to go ahead and use the 720p and take our focal length. Let's bring it down to 50. And anti-aliasing, we're going to need at least 2 because otherwise it's going to be really grainy. And sampling pattern, I'll set to blue noise. I'm going to leave off the adaptive sampling. The render will look better with it on. And View also renders its materials and everything with an adaptive sampling, along with the lighting and most of the indirect lighting, and bucket rendering, bucket sampling, which can be defined in the render options. You can also turn that off. If we go and take a look, and we would need to go to the advanced render options. We can set up customized settings for the indirect lighting, how many samples, and set up the adaptive sampling, where there's also a jittering with reduced pulsation, which is supposed to reduce flicker, and bucket size. The larger the size, less quality. So if you need higher quality, you can reduce this. If you're noticing any flicker caused by the lighting, you can also show the samples within the render to get a better idea of how things are being calculated. It will increase render times the smaller the bucket size. Just going to go ahead and cancel that. And I'm going to change my multiplier to 50%, just render it out a little smaller. Okay, so here's the render. The brown terrain preset, the material for it isn't great, and so it doesn't really have a whole lot of interesting colors in it. A lot of that really has to do with one of the changes between units from version 7 to version 8, and the preset was never updated. So what is controlling the color distribution, the number output for that is incorrect, and would need to be modified in order to actually see what is rendered with the preset. We can take a look at that in just a second. I do want to note, really can't see much of the foam, mostly because of the scale. The grid size is 500 meters at the moment, and the foam is 2 meters from the coast. So, or basically any object 2 meters below is going to show foam. So it's going to be a very, very thin line. So we would need to increase the foam extent. Also, the water is extremely clear. I think a little too clear. So we're going to adjust a couple of different options for the sea level object. We're going to start by modifying the material. So we're going to go and edit the object material. Oh, did have the wrong object selected. So selecting the sea level, edit object material. We're going to go into that foam, and what we can do is adjust the depth. So let's go ahead and increase this to 50. So that's really going to bring that up. And so that's just the foam layer. The main water layer is the default water. You can also load in additional waters. First, we'll go ahead and take a look at adjusting the transparency. So under the default water, you can go to transparency, and there's a fading out option. This will allow you to modify the coloration of the water and also how clear it's going to be. I also want to go ahead and add an additional 3 on the refraction index to make it more accurate. We can adjust the turn reflective with angle, which is basically kind of a Fresnel effect on the water surface. So you can make it look a little better sometimes by turning that up a little higher. Sometimes what I like to do is also turn on the anisotropic lighting, or highlighting, and just add a little bit to it. And it really helps pick up the highlights. Okay, so if you do want to load in a different material to be compatible with the sea level object and the current setup, if you go to liquids and meta waters, there are a couple of different options. Really just a couple. 2 that are going to be directly available to adjust the coastline foam, default water, and then the wavy shore. Wavy shore doesn't look too bad. It works pretty well for big waves coming in. It can be animated. The channel water is set up a little bit differently. For the most part, the main controls can be still edited within the water object interface. But these are the main waters. You can, of course, load any of the waters or liquids or any material you want on the object. But for the most compatibility with the sea level object settings, which I'm going to bring up right now, the meta waters work best. So we can go to Edit Object, and this is going to pull up the water surface options. We can adjust the surface altitude, which is the height of the sea level. There's a global wave control, which is basically just an overall setup between a very calm water and a very choppy, intense high wave water. So that's the agitation between calm and storm. You can also set the wind direction because it is animated and automatically animated. You can also choose to go in and modify these settings manually. Now you can already see that the typical depth, which is set to 50 meters, is exactly what we set the foam to within that meta node in the function. So these are directly connected to each other, and you can modify the actual function in meta node creating the water by going into the material or using these different options. So I'm going to use the global wave control. There's also the option to use the displaced water surface. First, let's just go ahead and take a look at this current setup. Right now, the water settings are controlling the bump of the material. So if we go into the object material, default water, go to bump, edit the function, we're going to find the waves meta node, where we have all of those options from the sea level object, plus some additional options, and the ability to edit the small wave rotation and go into the actual node that is generating the water. You can customize it and change it for a bunch of different nodes. The main fractal is the open ocean fractal node, and this is really what's creating the majority of the water. All of these little publish icons make the settings available within the main editor. So right now this is all controlled by bump. It's not actually geometry. So let's go ahead and take a look at the new render. So the foam is still at a point where it's still really not able to see it. Once again, grid size 500 meters, so I would need to zoom in a bit closer. But you can see that the clarity of the water was changed. I also want to note you can change the overall size of the water and the material. So if we go to, we can edit the object material and do it within the material editor, the advanced material editor, or we can go to the object properties and just modify the scale for the entire sea layer. I'm going to go into the camera, and we're going to bring down the camera and move in much closer to an area of the terrain so we can see a little more detail. Now, there does appear to be a rather large difference between what is showing in the OpenGL and what is rendering. And basically, I see no terrain whatsoever within the render. So chances are all of that's under the water, and for the most part it should match up, at least be pretty close to it. So what I'm going to do is go to the options and change the infinite procedural terrain geometry size down to, let's go ahead and use 10 kilometers. This way we should be able to increase the quality of the preview, and it has also updated. So if needed, we could also go into the edit object, so opening the terrain editor, and then just closing it right away. So just opening it, clicking OK, will update the terrain. So let's grab the camera. And I'm going to go ahead and find a better spot. So these areas should be rendering correctly now. Okay, so we're still not close enough to see the foam, and really I think I might just need to change the input over a little bit and manually change the distance to object below unit from the view unit possibly over to the meter setting. But I'm still really high up for the most part. So I'm going to go ahead and make some adjustments. So let's go down to this coastline, just a rotation. So we can kind of start to see the foam showing, but for the most part the intensity isn't very high. So what I'm going to end up doing is going into the sea level object, and I'm going to start just by editing the object itself, turning off the global wave control, and then the foam along coasts. Looks like the typical depth got reset somehow. Go ahead and set that back to 50 and increase the amount, and we'll add a little bit of wave coverage. Maybe increase the wave amount. Having a little bit of some weird things happening here. Where the terrain is now different than it was before. So, just going to try to find a better spot. I'm going to go ahead. It's possible that the terrain itself just created a reduced quality. So we're going to edit the terrain object, click OK, and hopefully refresh that terrain. So it looks like editing the water object did just throw off the proxy. And even though the terrain will disappear within the LIGHTwave OpenGL, that doesn't mean that it won't render. The range that is set is really just to create these proxy objects. The actual view terrain is rendering always to the end of the scene. So let's go ahead. This looks a little interesting. And hooray, we have foam. Of course, it's way too intense and doesn't look all that great. But at least it's showing up. Any object we put in the water is going to generate foam as long as it has a bit of slope to it, to extend outward. In other words, if we were working with a terrain that was very, very steep cliffs, we would need to have a much higher typical depth amount in order to calculate the foam. These are some examples I made back when View 7 came out. So this is the way the typical depth works. We've got the terrain extending below the water, and the depth is going to be, if it's 30 meters, everywhere and any part of the terrain that is 30 meters below the water object is where the fall off and the end of the foam will be. And then it'll gradually increase to where the water intersects with the terrain. Also, the wind direction. This is how the wind direction works, and what angles where it's coming from. So 360 and 0 is going to be from the positive x, and now keep in mind this is with the z-axis up. So 90 is positive y, 180 is negative x, and 270 is negative y. So that way you can set your wind direction based on that. Some other examples. This is the calm setting. So using the global wave control, no other changes. This is the calm setting, and up towards storm, we can see a much choppier surface, a lot more detail. This is the foam over waves, so seeing the foam being generated over the large peaks, and this is with a lower coverage amount of the foam over waves. So basically it's a calculation of the higher points of bump, or if you're using the displaced surface, the higher altitudes that will generate the foam. So if we did want to use real geometry for the water, go to the object and select sea level, and what we're going to do is edit the object and select the displaced water surface. Now what this is going to do is remove the connection in the material for the bump control, and instead this water surface object becomes another infinite terrain, and the function controlling this terrain is the waves. So what was controlling the bump of the material is now controlling the geometry and the height of this pseudo-terrain object. Or I guess it would be pseudo-water object, because it really is basically just an infinite procedural terrain. And back in version 6, before infinite terrains, procedural terrains were used to generate this kind of water using the open ocean. So this is definitely much more refined now that certain settings have been set up for you to make it a lot easier to make more realistic looking water. I'm going to go ahead and select the terrain, and right now its position is set to 162. I'm going to go ahead and set this up to a kilometer. Actually, that might have been too high. Let's go ahead and try 50 meters, 500 meters, 125 meters, and I just want to raise it up a bit. I'm going to go ahead and just use the handle and raise that up manually. I'm going to raise the terrain up much higher than the sea level so we can see much more of the terrain. Go ahead and grab the camera, edit the position, move that out so we can really see the terrain. I'm going to save the scene, so file and save since it is not incorporated, and really the LIGHTwave scene doesn't even need to be saved because everything is part of the view scene. Did just do something very strange though, and basically it was just a deconstruction of the geometry quality of the procedural terrain. So I'm going to select the terrain, and going to edit the object, and then click OK. And close out the terrain editor. And we'll get our higher quality preview. And the water object proxy is now also transparent, which it wasn't before. So that is a nice improvement. So we're going to use this scene, continue further, and take a look at the spherical scene option and planetary terrains.